In this example, we'll see how to determine support reactions under three different loadings. The first step, as usual, is to create a free body diagram. To create a free body diagram, we put all the loads and beam in place and put support reactions in place of the supports. So as B is the beam, it has vertical reaction By and horizontal reaction Bx, and A is a roller support, so roller support has vertical reaction only, which will be Ay vertical. Now the next step is to use the equilibrium equations. Equilibrium equations means summation of forces in the x direction equals 0, summation of force in y direction equals 0, and summation of moments should be equal to 0. Before using that one, we need to have some sign convention. As normal, we use vertical upward positive, horizontal rightward positive, and moment in anti-clockwise direction positive. Now let's take moment equals 0, and to take a moment, pin support is obvious choice because we can see out horizontal and vertical reactions at pin support if we do that. So moment about B equals 0. First one is Ay vertical reaction times 10, and it is creating clockwise moment. So that's why it should be negative, because our assumption is anti-clockwise positive. Second is the load 5 times 3 is uniformly distributed load, and the distance is 7 plus 3 by 2, and this is creating anti-clockwise rotation. Third one is 10 times 7 meter distance, and it is also creating anti-clockwise rotation, so it should be positive. And the last one is 60 kilometer moment, which is clockwise, so that should be negative, and the summation of all those should be equal to 0. This gives us 10 times Ay plus 127.5 plus 70 minus 60 equals to 0, which gives Ay equals 13.75 kilonewton. And the value is positive, means the direction as we assumed is correct. Now as we get Ay equals 13.75, we can use the next equilibrium equation, which is summation of Fy equals 0. In this system we have two vertical reactions, Ay and By, so both of which are acting upward. Ay we calculated upward, and By we assumed to be upward, and the vertical downward forces are uniformly distributed load 5 times 3 and vertical downward point load 10 kilonewton. So substituting the value of Ay 13.75, we can calculate the value of By, which equals to 11.25 kilonewton, and we get this one also positive, which means our assumed upward direction of By is correct. Now the last equilibrium equation, which is summation of Fx equals 0. As there are no horizontal acting forces, Bx is equal to 0. Now we can check if our values are correct or not. Because we have initially assumed summation of moment at B equals 0 to calculate the reactions, now we can use moment at A equals 0 to check if the values are correct. So Bx times 0, By times 10, the reaction time 10, and it is acting in anti-clockwise, so positive. So 60 kilonewton clockwise negative, 10 point load times 3 also negative, and 5 times 3 times 3 by 2, the distance from A to the point of action of uniformly distributed load, which is also negative. So this gives us 11.25 times 10 minus 60 minus 30 minus 15.15 equals 0. So we get in both hand sides 0 equals 0. So our reaction calculations are correct. So we can finalize our results. AY equals 13.75 kN acting upward. BY equals 11.25 kN which is also acting upward, and Bx equals 0.